Okay, let's do another example now. But remember, I was saying you could use substitution or elimination, okay? So on that last one I did a substitution, right? This one, let's try using elimination, okay? And to be honest, it doesn't really matter a lot of the time, but there are some times when it's better to do one method than another. This one, elimination will work because I have the same things on both equations. So it won't get too messy when I try and combine these equations together to get a new equation, right? But if I don't have the same like x squared and y here, like if they don't really line up very well, the equations, you probably want to go with substitution, okay? So let's do elimination. And I can eliminate either x squared in the equation or I can eliminate y. It doesn't really matter. I'm going to eliminate x squared. Okay, I'm going to get that out of the equation. So to do that, I need to make these opposite signs and the same numbers so that when I add them together, they cancel out to 0. So what I'm going to do, I'm going to take equation 1, I'm going to times it by, well, to get it to be opposite of this one, I'm going to need a negative, and I'm also going to need a 5, right? So we'll maybe do -5 times that top one all the way through, okay? So I get -15x squared, okay, minus 10y is equal to, and I need a handy dandy calculator, 5 times 26, got my pink calculator here, 130, so -130 here. Okay, whoa, come on there. Okay, there we go. So I just times by -5. This one, I'm going to get it to cancel out, I'm going to times it by, well, on this bottom one, I just need to times it by 3 to make it match up, right? So I'm going to times it by 3. I get 15x squared plus 21y. This is equal to 9. Okay? So we've got two equations that we've manipulated so that when I add these two together, the x squareds go away, right? And that's the whole point that we were going for here. So let's go ahead and add these together. Those cancel out, and I get 11, 21 minus 10 is 11, y is equal to -121, I believe, right? So 11y equals -121. I'm just going to divide by 11 now, and we get -11. Okay? So that's our y. So remember, our steps with elimination are you want to get one of the variables to have matching opposite coefficients, right? So that you can add them together and cancel them out, right? Then you solve for the variable in the equation. And now we just need to substitute in this y to figure out what x is, right? I'm going to plug this back in to one of the equations to find x, okay? So I get 5x squared plus 7 times -11, this is 3. Okay? So now I just solved this equation for x. So I get 5x squared, 7 times negative 11 is negative 77. This equals 3. Now we just add 77 to both sides of the equation. 5x squared is 80. Divide by 5. Let's see, 80 divided by 5. My brain does not want to do calculations today, guys. 16. Okay. And now I just square root both sides of the equation to solve for x. But be careful, if you do a square root to solve this, what do we need to throw in? We need to have a plus or minus, right? Whenever you take a square root, you do plus or minus, right? So, and square root of 16 is just 4, so plus or minus 4. So in other words, there's two different x values that work here. Oops, sorry. But only one y value, right? So in the end, my answer from this should be points, right? So I just do my two x values. One of them's 4. The other one's negative 4. And then I've got negative 11, negative 11 are my y values. They both be the same y value. Okay? So that's my answer here, would be these two. Okay? So not too bad, right? It's not too bad to solve these. We just do the same sorts of methods that we did for linear equations. There's just maybe a little bit more going on with these ones than the other ones, okay? If you want to see a graph of that one we just did, here is one for you. So we had 3x squared plus 2y is 26. That's this red parabola here, okay? Since they both had x squareds in them, they're parabolas. And then the y's didn't have squares, so they're just parabolas, okay? So then this other one looks like this. They intersect in 2 points, 4, negative 11, and negative 4, negative 11. We found both of the places where they touch, okay? Pretty interesting.